This is section 1.1. Use the figure to name each of the following. Number 1, a line containing point X. There are different answers that you can use for this. Some sample answers would be line M. You could also call it line XR, or XY, or YR. Number 3, a plane containing points W and R. So points W and R both lie in this plane B. You could also call this by 3 non-collinear points in the plane. So it could also be called plane XWY, for example. Number 5, name the geometric term modeled by each object. A floor. So a floor, let's say that this is the floor, and then you have a wall here and a wall back here. So the floor would be a plane. Number 7, draw and label a figure for each relationship. Plane Z contains lines X, Y, and W. Lines X and Y intersect at point V. Lines X and W intersect at point P. So the information we want to pay attention here is that X intersects both Y and W, and all 3 lines are contained in the plane. So if we start off, so this is for number 7, drawing our plane and labeling that. So here's plane Z, and we want 2 lines that intersect the same line. So they both intersect X. So that would be our line X. And we could call one of these Y and the other one W. X and Y intersect at point V. And the other 2 lines, X and W, intersect at point P. Number 9, name 3 points that are collinear. So 3 points that are on the same line. We could say that A, H, and B are all on the same line, or B, J, and F. So there's different answers that we could have. I'm just going to say the first one there. So line A, or point A, H, and B will work for us. Number 11, are points B, D, and F coplanar? Explain. So to answer this question, we need to look at those 3 points and see if they lie on the same plane. Okay, here's plane BDF that intersects with all 3 of those points. So our answer would be yes. They are coplanar. since all 3 points lie on the same plane. On number 13, name the lines that are only in plane Q. So in plane Q, we have 3 lines here. We have line N, line Q, and line P that intersect with that plane. 2 of those lines are in the plane, and that would be lines N and Q. Line P goes through the plane. So for number 21, does line N intersect line Q? If I extended this line out, because that's what the arrows mean, that it keeps on going on into infinity, eventually those lines are going to intersect. Sorry, that's hard to read, but it says yes if the lines are extended. For number 25, if we look at the pink object here and the other pink object, basically we have a plane here and a plane here. And those 2 planes are intersecting at this line. So 2 planes intersecting along a line. So for number 29, the edge of a desk. So if I draw a line along the edge of that desk, that's what the edge would represent. For number 35, 3 lines intersect at point J, but do not all lie in the same plane. So I could have 2 lines lying within this plane, and then another line that goes through the plane, intersecting with the other 2 lines inside of the plane. So 3 lines intersect at point J. Put that right there. But do not all lie in the same plane. 2 of them can, as long as the third one does not. For number 39, lines S and T intersect, and line V does not intersect either one. So we can start our diagram out the same way, where we have 2 intersecting lines contained in the plane, and then maybe above that plane we have a parallel plane and a line contained within that plane. So try to imagine that this plane is parallel with this plane, it's above it, it's stacked above it. So this line and these 2 lines, these would be called skew lines. So this line would extend out, these 2 would extend out, but they would never intersect each other. Number 43, name 2 collinear points. So I just want 2 points that lie on the same line. Notice that the word collinear has linear or line in it. So there's a lot of possibilities here. I'm just going to go with this one. It's pretty obvious that points P and M would lie on the same line. But like I said, there are plenty of possibilities there. Number 47, are points T, S, R, Q, and V coplanar? Explain. So T, S, R, and Q are coplanar, but V does not lie in the same plane as the other four. So our answer, even though four of them are coplanar, is no. Number 51, two-point perspective drawings two-point perspective drawings use two vanishing points to convey depth. Step A, trace the drawing of the castle shown. Draw 5 of the vertical lines used to create the drawing. So we want vertical lines going up and down. There would be 1, 2, 3, 4, 5. And there are many others, but that would be 5 of them. Part B, draw and extend the horizontal lines to locate the vanishing points and label them. So I would have a vanishing point here where these two lines intersect, and I would also have a vanishing point over here so VP for a vanishing point on the other side. Part C, what do you notice about the vertical lines as they get closer to the vanishing point? So let's take a look there. We have vertical lines on this side of this tower, and notice how far away they are spaced. And then we have vertical lines for this tower, and what I want you to notice is how far they're spaced apart. So as they get closer to the vanishing point, they get closer together. Okay, number 57, sketch 3 planes that intersect in a line. So hopefully this won't be too messy. Okay, so I had some technical difficulties, but I went ahead and paused it and drew that for you. We have 3 planes here intersecting along one line. So we have the plane we have this plane. Here's the second plane and the third plane, all intersecting along this line. Number 59, what is the greatest number of planes determined using any 3 of the points A, B, C, and D if no 3 points are collinear? So basically we have 4 points, and we want to choose all the different ways to choose 3 points from the 4 where the order is not specific or not important. So we could have plane ABC, we could have plane ABD, we could have plane BCD, or we can have plane ACD. So a total of 4 planes. And number 61, refer to exercise 49. Give a real-life example of a finite plane, or a plane that has boundaries. So an example for that could be a desktop or a tabletop, because it has boundaries. Is it possible to have a real-life object that is an infinite plane that continues on forever? Explain your reasoning. And we would have to say no, this is not possible in real life, because all objects in real life must have some sort of boundary.